Hi everyone, welcome to Numbers Simplified. Today we'll be looking at two methods for synthetic division of polynomials by a linear divisor. Before you move on, I encourage you to go over our part 1 video to familiarize yourself with the concepts if you haven't already done so. The link is in the description below. With the form that is given here, where we have the dividend and the divisor, remember P is the polynomial of the nth degree, AB are not equal to 0, AX plus B not equal to 0 either. Recall in part 1 we had A equal to 1. Anyway, so the first method is about using the synthetic division the normal way, then dividing the final answer by the A except the remainder. Every other thing remains the same. So now let's look at the example. The example that we have over here, we would carry on with the usual synthetic method. We find lambda. After we have set x being equal to lambda, we equate the divisor to 0, then lambda is minus half. We deal with the numerator, which is in this case the dividend. We have 4 as the leading coefficient, which we drop. We multiply that by lambda. In this case, it's minus half. So we are going to have a minus 2, minus 32 minus 34. Minus 34 times lambda gives us 17 plus 5, 22 times lambda. We are going to get minus 11 plus 11, that's a 0. So our answer is that, but that's not the final answer, by the way, because we have to divide by the 2, which was the A. So dividing that by 2, our final answer becomes that which we have there. Now we move on to method 2. We'll use the same example, but now one thing to take note of is the coefficient of A has to be 1 all the time. Now, so we'll use the same example. We divide both sides by A. So dividing the dividend and the divisor by A, we're going to have P of x over AX plus B. You recall that dividing by A is the same as multiplying by 1 over A. So we're going to multiply the dividend by 1 over A as well as the divisor by 1 over A so that we have it in that format. Now, simplifying that, we would have 1 over A times P of x, and that will be over x plus B over x. And then we apply the normal synthetic division, and that is it. Now, looking at the same example, we are saying that the A is equal to 2, which is the coefficient of x in the divisor. So we are going to divide throughout by 2 or multiply throughout by 1 over 2. In doing so, we have that in the numerator, and we have 1 over 2 times 2x plus 1 as our new divisor. So then, meaning that simplified, we would have 2x cubed minus 16x squared plus 5 over 2x plus 11 over 2 all over x plus 1/2. And there we go. Now from here, we use the usual synthetic division. So we are going to obtain our lambda, and as you may recall, we make the x in the denominator be equal to lambda. We set the denominator or the divisor to 0. Then we solve for lambda. In this case, our lambda is minus half. From there, we separate the dividend according to the coefficients, starting from the leading coefficient, which is 2. Then from there, we drop the leading coefficient without doing anything to it. We don't multiply anything. Now, from here, we multiply that 2 with the lambda so that we get 2 lambda. In this case, we get a negative 1. Negative 1 minus 16, we get a minus 17. We multiply that by lambda. We get 17 over 2. Adding to 5 over 2, we get 11. We multiply that 11 over 2. That is negative actually. With the positive 11 over 2, we get 0, and we get our final answer. From now on, we'll continue with method 1 because it is easy and simpler, which is the purpose of this channel anyway. But I'd encourage you to check out our other videos. Remember to subscribe, like, share to get new videos. Now, moving on to example 2, we are going to start by the divisor, get what the value of lambda would be, knowing how we get to the lambda by setting the divisor to 0 after we've substituted for x is equal to lambda. Then afterwards, we move on to get the coefficients of x in the dividend. So that is what we would have, including also the 0 terms in between the x values that we may have in between. Right, so we drop the first coefficient, which is the leading coefficient, 32 in this case. We multiply that one by lambda. So when we do so, we are going to get a value of 48, and that multiplied by lambda, we are going to get 72. 72 plus 8 equals to 80 times lambda, we get 120. So that plus 0, we still get 120. Then that multiplied by lambda, we get 180. So 180 plus the 2 that we have above there, we would have 182. 182 times lambda, we get 273, which is positive, plus the negative 1, we get a 0. And that gives us what we are looking for momentarily. So that's what we are going to do. And remember, we get the coefficient of the value of the variable. Remember, the first value that we take is the one that we have as our leading coefficient, and it has to be 1 degree lower than the one in the dividend. But remember, we have our a being greater than 1. So we're going to divide throughout by the 2 so that we get our answer as this one. Now we move on to the next example. So in the next example, the only difference that we have is in the divisor, where we have a positive instead of a negative from the previous question. Right, this one was done for a reason of introducing the idea of the remainder theorem. We find our lambda as usual. We also separate the dividend into that table. Then we drop, of course, the leading coefficient, which is 32 in this case. We multiply that 32 by the lambda after we have dropped it. So we are going to have a negative 48. So negative 48 plus 0, we get minus 48. Minus 48 times lambda, we get 72 plus 880 times lambda, we get minus 120 plus 0, still minus 120 times lambda, we get 180 plus 2, we get 182. We multiply that one by lambda, we get a said positive. Actually, it was negative. So that's it and done. We divide throughout by 2, excluding the remainder. So that will be our answer there. If you've made it thus far, thank you so much for watching Numbers Simplified. I'll leave you with this task below. Make sure you work on it and let me know of the answer. Your comments are always welcome. Let me know the topics you want us to look at together and the ways we can improve our channel. Once again, remember to share, like, and subscribe. Thank you for watching Numbers Simplified.